In this lecture, we will talk about applications of all those formulas. Okay. Before we talk about applications or examples, I want to review the signs for sine and tangent. Okay. We know that sine is y-coordinate. Okay. If the angle is in first quadrant, we have xy coordinate. And then we know sine is y. And for this angle, the angle is in quadrant 2. Sine is also y. In this case, y is positive in quadrant 1 and 2 for sine. Okay, so I wrote sine is positive. Okay, so down below here, that means in the third quadrant and fourth quadrant, you have a negative y. Okay, so sine is negative in quadrant 3 and 4. Now, let's look at tangent. Tangent is sine over cosine or y over x. In quadrant 1, you see that's positive over positive. Y over x is positive. So tangent is positive in quadrant 1. In quadrant 3, tangent is negative y over negative x. Okay, so negative over negative is positive. That tells us that tangent is positive in quadrant 3. Okay, so tangent is positive in quadrant 1 and 3. This also tells us that in quadrant 4 and 2, tangent is negative. Okay, so with these things in our mind, we can do the first question. The first question says that find the exact value with the given conditions. We are given sine theta is negative 5 over 13 and tangent alpha is greater than 0. Okay, so we want to find out sine alpha minus pi over 3. Yeah, we want to find out exact value. So here is sine alpha minus pi over 3. You got to use which formula? You got to use formula 3. Sine, negative. So formula 4. Sine is sine, cosine, cosine is sine. And then if here is negative, then here is negative. So here you just need to do is sine one angle minus another. Sine, cosine, cosine, sine. That's based on the formula. So you have a negative here, you have a negative here. Okay, that's for sine. Alright. If you have a positive, then positive. If you have a negative, then negative. Those two are different from cosine. They are opposite. Okay? Cosine is negative, positive, positive, negative. Alright. So, down here we know cosine pi over 3 is just 1/2. Sine pi over 3 is radical 3 over 2. Again, y up to this far, you know, this picture should be in our mind. 60 degrees, that's this angle. Cosine is adjacent over hypotenuse, so that's 1 over 2, 1/2. sine pi over 3 radical 3, opposite side radical 3 over 2. Okay? So that will be radical 3 over 2. Okay, now we need to figure out those two. Sine theta is given, negative 5 over 13. So we got to figure out cosine. If we have this value, then we are done. Okay? So the key issue for this example is that we want cosine alpha. Now, here is the way to figure out. First, you don't need to look at the sign. You are given sine alpha is 5 over 13. You don't need to look at this negative sign. Then you have a right triangle. Remember, sine is opposite side over adjacent, over hypotenuse. So alpha must be here. Okay, if here is 5, here is 13, because that's opposite side over adjacent. Okay, then that will be 5 squared plus a question mark squared, this leg squared, should be equal to 13 squared. Okay, and then 5 squared is 25, 13 squared is 169. Both sides minus 25. You cancel 25 on the right hand side. The left hand side is 169. That's 13 squared minus 25 give us 144. So question mark squared, this leg squared, is 144. If you choose square root, you will have a 12 for this leg. Okay, so this leg is 12. That's what I wrote here. Then you will have a cosine. Cosine is adjacent over hypotenuse. Then you know it's 12 over 13. You know the value is 12 over 13. So you have a cosine alpha. But remember, here we want to figure out cosine alpha is positive or negative, because sine alpha is negative. Okay? So in which quadrant this alpha is, we need to figure out. You know, previously, a minute ago, I have reviewed that sine is negative in quadrant 3 and 4. So this alpha is either here 3 or in quadrant 4. And the tangent we are given is positive. So it's either in quadrant 1 or quadrant 3. Okay? So then this case tells us that sine is right here, either here or here, but tangent tells us it's either here or here. So this tells us alpha is in quadrant 3. In quadrant 3, cosine is negative. See, we have negative y. See, we have negative y. So it tells us that cosine alpha is negative 12 over 13. Again, here there are two steps. One is you figure out the values by using a right triangle. Then you figure out the sign by using this picture. Okay? Those y, x, y, negative x, positive y, negative x, negative y are very abstract. If you want to use the concrete example, you want to look at this picture. Okay? Yeah, I will put this one on my notes, and then you can print it out. Okay, so basically here is our x, the first coordinate is our x. Okay, and this is our y. Alright? Yeah. Then you have a negative x, negative y, like here, negative x, negative y. You have a xy here. Okay? So x in this case is 4 over 5, y is 3 over 5. Alright? So you may use this concrete example to figure out the signs for positive, negative thing. Okay? This example, picture I draw here is the actual value, and here is a little bit abstract. Okay? Alright, so then we are clear here is negative 12 over 13. And then you just need to add those two numbers together. We know 2 times 13 is 26. 2 times 13 is 26. So denominators are the same. Negative 5 times 1 is negative 5. Negative negative is positive. So that's positive 12 times radical 13. Radical 3. Okay? This is the exact value. Okay? So not many steps. The thing again right here is this value for cosine alpha. You got to use two things. One is the right triangle. Another is using this picture to figure out the symbol of cosine, or using this concrete example. Okay? Alright. Now, let's look at the second example. The second example is that we are given sine alpha is negative 3 over 5. Secant beta is 5 over 4. And then for a third quadrant, angle alpha. So we are given alpha is in the third quadrant. And you know that's why here sine is negative. And the first quadrant angle for beta, that's why you know secant beta is 5 over 4. Okay? Find the following. We want to find out this tangent. We want to find out tangent. Tangent alpha plus beta. And then we need a formula, which is this formula. This formula. Okay? If here is tangent alpha plus beta, then you will have a tangent alpha plus tangent beta. And here, downstairs, if here was plus, then here has to be minus. Okay, so plus here, then plus here, minus here down on denominator. And this two is just the product of the first numerators, 2/10 of numerators. So we got to use this formula. Okay. Alright, so you want to write here is tangent alpha plus beta is tangent alpha plus tangent beta. Downstairs you always have 1 minus. Again, here is plus, here is plus. Downstairs is opposite. And then minus the product of those two tens, tangent alpha, tangent beta. Okay, now we need to figure out all those values. Tangent alpha, tangent beta, actually we need to figure out all those two values only. But we are given alpha, sine alpha we are given. And then if we can figure out tangent alpha, similarly we can also figure out tangent beta. In order to figure out tangent alpha, then you have two steps. One step is what? Using the right triangle. Okay? So you know this is alpha, And then 3 over 5. 3 over 5. 3 over 5 is sine. Then you have a, here this side is 3, hypotenuse is 5. This side will be 4. Because of what? 3 squared plus 4 squared is 5 squared. So this side is 4. 3 squared is 9. 4 squared is 16. Add together is 25. So 25 is 5 squared. Okay, so we know this is 5.